Okay, so first off, we have perpendicular bisector. So in this section, we're going to talk about bisectors of triangles. First, we're going to talk about a perpendicular bisector. And a perpendicular bisector is exactly what the name suggests. The bisector part, right, says that it's a line or a segment that passes through the midpoint of a side. Okay, yeah. No, a midpoint is a point. A bisector could be a segment, array, or a line. Okay, so that's the bisector part, and the perpendicular part is that it's perpendicular to that side. All right, so it's a line that passes through a midpoint and it's perpendicular to a side. So here it says draw a perpendicular bisector to BC. Where is BC? That's this side here. And if I want to draw the perpendicular bisector of this, well, bisector means it's going to pass through the midpoint. So first what you would have to do is locate the midpoint, and suppose that's the midpoint right there. Now your bisector is a line, okay, or array, or a segment that passes through this and is perpendicular. Perpendicular right there. So that is the bisector. That's the perpendicular bisector. And you can draw it at, so if it says it's the perpendicular bisector to segment BC, that's how you draw it. And of course you can draw it to any of the other sides. Yes?
To show that it's a midpoint, what do you have to do?
You do, yes. So here and here. Okay? All right, so here we have two very important theorems about perpendicular bisectors. The first is called perpendicular bisector theorem. Okay? What this says is, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So suppose, look, here you have segment AB. Okay? This is the midpoint of segment AB, and here is the perpendicular bisector CD, right? Now, suppose you pick a point on that line. You randomly pick a point, C, okay? And just for fun, you measure the distance between that point you picked and the endpoints. So you measure the distance between the point you picked and A, and then you measure the distance between that point and B, and guess what? Magically, if this is 5, then that ends up as being 5 too. So now you go, huh, that's an interesting coincidence. Let me try that again. So what you do is you pick another point randomly. Just close your eyes and you pick some random point on the perpendicular bisector. Okay? You measure the distance between that point and one of the endpoints. Okay? And suppose it's 7 centimeters or 4 centimeters. And then you go, okay, let me measure the distance to B. 4 centimeters. Okay? So no matter where the point is, as long as it's on the perpendicular bisector, it's equidistant from the two endpoints. Okay? All right. And here is the converse of it. So the converse says, all right, so here you are at this point, okay? And you notice, oh, it's the same distance to B as it is to A from where you are. So you tell yourself, oh, I must be on the perpendicular bisector of AB, okay? So that's what the perpendicular, that's what the converse is. So if a point is equidistant from the endpoints, then it is on the perpendicular bisector. Okay? Questions? Yes, no? Okay. So let's move on. we're going to prove theorem 5.1. We're going to prove the perpendicular bisector theorem, which said that if a point is on the perpendicular bisector, then it is equidistant from the two endpoints. All right? To prove this theorem, again, we need auxiliary lines. Okay, so in this case, all you have in reality is this horizontal line and this vertical line. You put in the auxiliary lines, right? Because you're measuring the distance between the 2 points. Okay, so what we are told to start off with is that segment AB is the perpendicular bisector of segment CD. That implies two things, that this is a 90-degree angle and that these two portions are congruent, right? Because that's the definition of perpendicular bisector. So what I want to do now is I basically want to show that this line and that line are equal to each other. How do we do that? Chapter 4. Okay? So I want to prove the triangles are congruent and then CPCTC. Okay? Can I use HL for this one? Can I? No, because that's what I'm trying to prove. All right? But what can I use? SAS. Okay? All right. So first off, I have the 90-degree angle. So 2, okay? I can say angle AEC and angle AED are right angles. I can also say that CE is congruent to ED. Now, watch carefully. This is kind of cool. I can combine both of these in one step because the reason for both of these is the same, and that's definition of angle bisector. Definition of perpendicular bisector. Right? So perpendicular bisector gives you two statements. One is that the angle is 90 degrees, and two, that the sides are congruent. Okay, so here I have a side, and number 3, when I say that those two angles are right angles, I can say that angle AEC is congruent to angle AED. Why? And that's my angle part here, because all right angles are congruent. All right, what else do I need? A side, which side? AE, congruent to? SAS, congruence. Oh, sorry, I'm skipping ahead. Now, all right, so if I say triangle ACE, what would that be congruent to? ADE. And this is SAS congruence. Finally, I can say AC is congruent to AD because of CPCTC. Okay, yes.
What are the lines on the bottom for? Like, do they need to be there?
No, that's just to show that B is also on the perpendicular bisector, right? So you could also do it using, BC and BD, right? Instead of AC and AD, you could also, you could also do these two triangles. That's a right triangle too. But you have it on both sides. It's symmetric. Do you see what I mean?
No, like the big one. Yeah. Like ABD.
A, B, D. No. So the point of it is you can either use this triangle or this triangle, 1 and 2 together, or 3 and 4 together, and prove that CB is congruent to BD. Okay? For the way this proof is drawn out, you don't need the bottom lines. Okay, so solve for X, knowing that SR is the perpendicular bisector. So if these are the types of problems that, really show up on the stuff. So if SR is the perpendicular bisector, that means R lies on the perpendicular bisector. That means it's equidistant from the two endpoints, right? Which are the endpoints? Q and T. Okay, so that means 2x plus 3 is equal to 4x minus 7. 2x equals 10, x equals 5. And we also need to find RT, which is 4x minus 7. So that's 13. Okay. Moving on. Okay, so let's talk about angle bisectors next. Yes.
We're going to go to segment RT or
RT equals 13. Angle bisector is a ray, and what it does is it divides the vertex of a triangle into what? Two congruent angles. Okay, so to draw the angle bisector, for angle B, all I have to do is bisect it. It's a ray, and we show that the angles are cut in half. Okay. Given that AD is an angle bisector, find measure of angle ADC. So that big angle ADC. Oh, this one, ADC. This is what we need to find. All right, so here, if this is 50 and this is 66, for these two, 50 plus 66 is 116. So this angle altogether is 180 minus 116, which is equal to 64. Now, if AD is an angle bisector, that means each of these are congruent to each other, so each gets 32. And once you have that, measure of angle ADC is 180 minus 32 minus 50, 98. So let's see about theorems for angle bisectors. We have two similar theorems for angle bisectors. The first is the angle bisector theorem, and it says if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So watch what that means. This is the angle bisector, BF. Now, suppose I'm here on the angle bisector, okay? And I measure how far away I am from the sides of the angle. So how far away I am from here and how far away I am from here. And it turns out those are the same. They're congruent, okay? So if this is 5, that's 5, okay? The one thing you have to be careful of is here, you're measuring the distance, right, between F and D. you have to make sure that you have to take the perpendicular line between F and D, right? That's how we measure distance, okay? And the converse of this is, suppose you're at this point F, and you measure the distance to D, and you measure the distance to E, and you see that they're equal, then you say, oh, I must be on the angle bisector, right? So that's the converse of the angle bisector theorem, okay? So let's prove that then, because that's just what we do here. And here I actually have a little bit of a, I didn't catch this before. I have a typo, which I didn't catch before I printed this. This is supposed to be perpendicular, and this is supposed to be perpendicular. Otherwise, it won't be a bisector. All right? So CD is an angle bisector of triangle ABC. Okay. EG is perpendicular to BC here. EF is perpendicular to AC here. All right? We need to prove that EF and EG are congruent to each other. Let me do this on the inside too. All right, so what we're going to do, since we know that it's an angle bisector, we know that those two angles are congruent, right? Okay, so what we're going to do first is write down what we're told, which is CD is an angle bisector. We're also told that EG is perpendicular to BC. We're told that EF is perpendicular to AC. Now we need to interpret this. All right. So perpendicular means that those two angles there are right angles. So angle EGC and angle EFC are right angles. Why?
Definition of perpendicular bisector.
Perpendicular lines. There is no perpendicular bisector here. Okay? All right, so what we need to do here is we want to prove this triangle ECF is congruent to this triangle ECG. Okay? To do that, I now have a pair of angles that are congruent. So that's what I'm going to say next. Angle EGC is congruent to angle EFC. Why? All right angles are congruent. So that's my A. All right, is there anything else? ACD and BCD are congruent. Why? Exactly. So angle ACD is congruent to angle BCD. That's my other angle. Definition of angle bisector. What else do we know is congruent? Well, CE and CE. Right. So now, triangle FCE is congruent to triangle GCE. AAS congruence. And what I needed to prove is that EF is congruent to EG, which I can say in my next step as CPCTC, EF is congruent to EG, CPCTC. So you see how you're basically using the same exact things as last chapter, but recycling them? All right, our proof's getting a little better now? Yeah. BCD. Okay, so let's move on to this next problem. We have an angle bisector. So remember, angle bisector says if you have a point on the angle bisector, it's equidistant from the two sides. So those two little portions are equal to each other, meaning 2x plus 6 equals 4x minus 1. So 7 is equal to 2x. X is equal to 7 over 2. Next, we need to find segment EF, sorry. And segment EF, the measure of segment EF is equal to 4x minus 1, which means it's 4 times 7 over 2 minus 1. These two cancel. 14 minus 1 is 13. Okay. All right. That takes care of section 1. Now, section 2 is about medians and altitudes. Okay. Again, same sort of situation. A median is a segment that connects the vertex or a vertex to the midpoint of the opposite side. So basically it goes from vertex to the opposite side, but to the middle of the opposite side. All right, here it says draw the median from B to AC. Here's the midpoint of AC. The median just passes through it. I think it's easier to move the midpoint. Okay? So then it just passes through it. Now, is that median perpendicular to AC? Doesn't have to be. Okay? There are no restrictions or implications of being perpendicular whatsoever. All right? Okay, so here it says find X if AD is a median of triangle ABC. Immediately you go in and you mark down what that means. Median means it passes through the midpoint, so these two are congruent to each other. Which also means that 4x plus 9 equals 7x minus 6, which means if you add 6 to both sides, this is 15, this is 3x, and x is just 5. Yeah.
So on this one,
Mm-hmm.
if that is going through B, does that mean that it's also in the angle bisector?
No. It just connects the vertex to the opposite side through the midpoint. Yes.
On the last one, I'm kind of confused because it says like the median of triangle ABC.
Right.
So like, how do you know like?
Well, the way it's drawn, you know that it's going to D. Okay, it's going from A to D. It's passing through segment BC. Right? The line that it passes through, that's the one it cuts in half. Okay? All right, next you have altitude. What does that word altitude mean? forget geometry. What does altitude mean? Like altitude of the height, right? And whenever you're measuring height, when you go to the pediatrician or the doctor and they are going to measure your height, what's the first thing they tell you to do? And then what did they tell you to do? Stand up straight, okay? So they tell you to stand up straight. He could also say, stand so that you're completely perpendicular to the ground, but I don't think many people would understand that, okay? But it's the same thing. So when you're standing straight, you're perpendicular to the ground, and that's the only way to measure height. Because if you're slanted, then you're not getting an accurate measurement of your height. So altitude is basically the height, okay? It's going to connect a vertex of a triangle to the opposite side such that it is perpendicular to that opposite side. So always remember that the altitude is the height. Oh, that's not height at all. Meaning it must be perpendicular. Okay. So the altitude goes from the vertex to the opposite side, and now it's got to be perpendicular. Here we have to draw the altitude from C to AB. So from C to AB, but make it perpendicular here. Okay? Does it pass through the midpoint of AB? Not necessarily. Okay, the condition is just that it's perpendicular, and that's the height of that triangle. Okay? So afterwards we'll talk about the implications of altitude in upcoming lessons. So here this question says find x and ij if hk is an altitude. So altitude, immediately, what do you mark on the diagram? Perpendicular, okay? Now we need to find x, so all we have is the information about the angle. That means 3x plus 3 equals what? 90 degrees. That means 3x is 87 and x is 29. Ij is x plus 8, which means it's 29 plus 8, which means it's... Oh, wait a minute. What's ij? What's ij equal to? It's x plus 8 plus x minus 9. I missed that part. So plus 28 minus 29 minus 9. Actually, I want to do it more elegantly. I don't like that. Yes, elegance is all that matters. So what is this? This is 2x minus 1. So this is 2 times 29 minus 1, which is 57. Okay? All right. So we're done with sections 1 and 2. This homework is going to be due tomorrow, which is Wednesday. Both assignments, yes, 5.1 and 5.2 due Wednesday, and the date on Wednesday tomorrow is the 18th. Are they quick? They're quick for me.